Good morning, boys. Today, I will start with problems which carry 3 to 4 marks in complex numbers. My first problem is how to factorize a square minus ab plus b square. And my second problem in this case is how we will factorize x cubed plus y cubed. Starting with this is an expression a square ab plus b square. And here it is minus 1. And this minus 1 would be replaced by omega plus omega square. While working out cube root of unity, we have an important property of complex cube root of unity. That was 1 plus omega square is equal to 1. Therefore, this minus 1 a square plus omega square ab plus b square, since 1 omega square is 0. So therefore this is replaced, minus 1 is replaced by omega plus omega square, which can be further written as a square omega ab plus omega square ab plus b square. From these two terms, I take a common, a plus b omega, and from these two terms, I take b omega square common. Left over is b omega square is taken out common, and left over is b omega square, that is a plus. When I take b and omega square common, this becomes b by omega square. I repeat once again, this minus 1 is replaced from this particular property of omega which we have done in our last part. So omega plus omega square is minus 1. Replace, and on further simplification, this is a plus b omega plus b omega square, a plus, I multiply omega to numerator, and this becomes omega cube, and omega cube is equal to 1. Therefore, a plus b omega plus b omega square, a plus b omega, using this condition, omega cube is equal to 1. On factor form, I can write this as a plus b omega. So therefore, this given expression can be factorized in this particular form, that is a plus b omega squared and a plus b omega, where omega squared, where omega squared are complex cube root of unity. This is first part of problem number 1. I move on to my second part, that is how to factorize x cubed plus y cubed. Number 2. X cubed plus y cubed can be written as x plus y, x squared minus xy plus y squared. This is a very common example there in your different exams. So therefore, I first factorize, writing it as x plus y into x squared minus minus xy plus y squared. This portion is in linear form, and this particular portion I may write it as plus omega square xy y square. This problem now reduces to the same form. I further simplify this as x plus y into x square omega square xy plus y square. If we should that 1 plus omega square as it is equal to 0, therefore omega plus omega square is minus 1. So therefore when this is equal to minus 1, I replace it by omega plus omega square, and on simplification x plus y, taking x common from these two, x plus omega y, plus I take from these two y omega square, x plus y omega square, bracket close. I am repeating this so that you get used to it, that wherever there is minus 1, we replace it by omega plus omega square. That is x plus y, x plus omega y plus y omega square, x plus y omega. I am multiplying both numerator and denominator by omega. That is x plus y omega square into x plus omega y, that includes x plus y omega square into x plus omega y, where say omega square are complex cube root of 1. So therefore, I have worked out two problems, that how do we factorize in case of complex number. If these two types of problems are given, you will factorize using the technique we have shown. I now move on to problem number 2. If x plus iy is equal to 2 by 3 plus cos theta plus I sin theta, so that 2x square plus 2y square is equal to 3x minus 1. Very common in your examination, this particular problem, but students make minor mistakes. We will proceed and try to follow what are the mistakes we need to avoid. Starting with this problem, I will write that is as x plus iy is 2 by 3 plus cos theta plus I sin theta, that is 3 plus cos theta plus I sin sine theta is equal to 2 by x plus iy. I am just simply reciprocating. I am replacing x plus iy by this denominator by my cross multiplication, and x plus iy is dropped down. That means simply the technique is bring this to the numerator, bring this to the denominator, so that is 3 plus cos theta plus I sin theta is equal to 2 x minus I theta x plus iy x minus iy, multiplying numerator and denominator by x minus iy. So that my reference triangle remains 3 plus cos theta plus I sin theta, that is 2x minus 2iy divided by x squared plus y squared. I have multiplied numerator and denominator by conjugate of the denominator by z bar, that is x minus iy. Denominator is my real part. This is real, x squared plus y squared. And in the numerator, it is 2x minus 2iy. That is 3 plus cos theta is equal to 2x by x squared plus y squared, and sin theta 2y by x squared plus y squared. I am equating now the real part with the real part, imaginary part with the imaginary part, so that 3 plus cos theta is equal to 2x by x squared plus y squared, because that is there in the right hand side, and in my left hand side it is minus 2y by x squared plus y squared. I have obtained this value, therefore cos theta is equal to 2x by x squared plus y squared minus 3, and sin theta is equal to minus 2y by x squared plus y squared. Now the point is very simple. Your question could be, why are we proceeding in this manner? Our main aim is to eliminate sin theta and cos theta. There is no sin theta, there is no cos theta, which I have to show. So therefore, I have to find a relation where sin theta and cos theta does not exist. They are eliminated, but x and y term exists. This is what I have done. I have determined value of cos theta. I have determined value of sin theta. How do I do that? I have simply made it reciprocal and multiply by its conjugate. This is A, the real part, the imaginary part, divided by this. So this is my real part and this is my imaginary. Now, as cos squared theta plus sin squared theta is equal to 1 to x by x squared. Do not take LCM of this. Leave it as it is in this particular form. If you multiply to 3, the problem will become huge and large. That is where the confusion starts. So avoid that. Let it be in this particular form. Plus minus 2y by x squared plus y squared whole square is equal to 1. Replacing value of cos theta, replacing value of sin theta, that is 4 x squared by x squared plus y square whole square plus 9 minus 12 xy x square plus y square plus 4y square by x square plus y square whole square is equal to 1. Take, understand, try to follow step by step. Each step should be thoroughly clear. Once each step is clear, you need not memorize. Start working these problems. Now, between these two terms, I take 4 common. 4x squared plus y squared, and my denominator is x squared, y squared whole squared, plus 9 minus 12x, x squared plus y squared is equal to 1. These two factors get cancelled. 4y x squared plus y squared plus 9 minus 1 is 8 minus 12x by x squared plus y squared. That is 4, 1, 4, 2, 4, 3. Therefore, 1 by x squared plus y squared plus 2, 2, 2 into x squared plus y squared by x squared plus y squared minus 3x by x squared plus y squared is equal to 0. So what I find is, without I have just squared and cancelled out this 2. When I have cancelled out, therefore 4y x squared plus y squared. 9 minus 1 is 8 minus 12x yx squared plus y squared is equal to 0. Now due to shortage of space, I have to move on to somewhere here. That is therefore 1 by 1 plus 2 x squared plus y squared minus 3x is equal to 0. That is 2x squared, 2y squared is 3x minus 1. This is what I have to show. So therefore, this is very important problem. Students generally make mistake in this. They make lot of mistake. They start with this term. If you start with this term, this problem will become rigorous and huge, and you won't be able to complete this. After this, I will go on to problem number 3. Express 1 plus x squared into 1 plus y squared as sum of 2 squares. This is our given expression. This is our given expression. And I have to express as sum of 2 squares this particular given expression. Now, how do I start? I cannot factorize x squared plus 1 by our real number concept. I cannot factorize y squared plus 1. But in the concept of complex number, it can be done. That is, I know as I squared is minus 1, this implies complex number. I is my imaginary quantity, and I know that I square is equal to minus 1. So if I square is minus 1, therefore I square is equal to minus 1. Therefore, minus I square is equal to 1. I replace both these 1 by minus I square, that is x square plus 1, y square plus 1 is x square minus I square into y square minus I square. If you start the problem correctly, then your half problem is done. So therefore, initially, how you start the problem, that is very vital. You have to know that how would I start a given problem. So that is, this is equal to x minus I, x plus I, y minus I, y plus y plus I. I have factorized this a square minus b square, a minus b, a plus b, a minus b, a plus b, and now these two terms are multiplied. X plus I, y plus I into x minus I into y minus I. Both the positive quantity are multiplied together. X plus I and y plus I is multiplied together, and x minus I and y minus I is multiplied together. That is, I may write this as xy plus ix plus iy plus I square. And this term will be written as xy minus ix y plus I square, which is further xy, this is minus 1, xy minus 1 plus I into x plus y, and while this particular part will be xy minus 1, since I square is equal to minus 1 minus I into x plus y. Just see what I have got as this as a plus ib and this as a minus ib. Conjugate of this complex number is this particular, which can be further written as xy minus 1 whole square plus x plus y whole square. I have expressed this particular given expression in this particular form, that is sum of two squares, by using factorization technique. For you, I am giving you an exercise, problem number 4. Express a square plus 1, b square plus 1, c square plus 1 as sum of 2 squares. All of you try this particular problem. It is same as this 1 factor c square plus 1. I have increased a square plus 1, b square plus 1 is similar to this, but I have added a factor c square plus 1. This is problem number 3 I have completed, and I have given problem number 4 as an exercise. I move on to problem number 5. Problem number 5 says Problem number 5. If argument of z minus 1 by z plus 1 is pi by 4, so that locus of z in the complex number is a circle. Now, let us start with, this is a locus problem. In Cartesian coordinate, you will find a lot of problems based on locus. And in that locus, we consider particular points, let P, X comma K be a point. And practically there are many problems, even in straight line, in circle, and in conic section of analytical geometry of 2 dimension. But here we start with let z is equal to x plus iy. Z is a complex number. Therefore, z minus 1 is x plus iy minus 1 is x minus 1 iy. And similarly, z plus 1 is equal to z plus 1 is equal to x plus iy, that is x plus 1 plus iy. Therefore, argument z1 minus 1 by z plus 1 is argument of the complex number x minus 1 plus iy divided by x plus 1 iy, and my right hand side is equal to pi by 4. Therefore, I use property of argument. Argument z1 by z2 is equal to argument z1 minus argument z2. Therefore, I will write this as that is, therefore, argument of x minus 1 plus iy minus argument of x plus 1 plus iy is pi by 4. That is tan inverse y by x minus 1. This is the imaginary portion. This is the real part. I will write tan inverse y by x minus 1, and similarly tan inverse y by x plus 1 is pi by 4. That is tan inverse y by x minus 1 minus y by x plus 1, and in the denominator y by x minus 1 into y by x plus 1 is equal to pi by 4. Follow this. I am using the tan inverse x plus tan inverse y formula. So therefore this is equal to y into x plus 1 minus y into x minus 1 divided by x minus 1, x plus 1 plus y square is equal to tan pi by 4. Tan pi by 4 is 1. So that is or xy y xy plus y is equal to 1. So therefore x square minus 1 plus y square. On further simplification, I get that is x square plus y square minus 2y minus 1 is equal to 0, which is an equation of a circle with center 0, 1 and radius root over 0 plus 1 minus plus 1 is equal to root 2 units. With this, I complete a very important problem of complex number. Thank you, students.